Hi, my name is Chris Stapler, and this is VP4 Problem 3, and it's number 8 in Chapter 3.3. And so we're given this equation 6x squared plus 2x cubed y double prime plus 21x y prime plus 9 times x squared minus 1y equals 0, and we're asked to find or determine whether x equals 0 is an ordinary point, a regular singular point, or an irregular singular point. And so I start by dividing everything by what's the coefficient, I guess, of y double prime. And so I'm left with this equation right here, y double prime plus 21 over 6x plus 2x squared y prime plus 9 times x squared minus 1 over x squared plus 2x y cubed y equals 0. And so then we get our p of x and our q of x, which we then use to find p naught and q naught. And so in p naught, we take the limit as x approaches 0 of this equation right here. Notice this equation is p of x, and we just multiply it by x. And so the equation we get after taking the limit as x approaches 6, which I just plug in 0 in, I get the limit does exist, and it's 7 over 2. And so we come down and we do the same thing for q naught, but we multiply q of x by x squared instead of x, and so we take the limit of that and plugging in 0, I find that the limit does exist at negative 3 over 2. So since we found both p naught and q naught to exist, like the limits of those to exist, and we got numbers for them, that means x equals 0 is a regular singular point. So then we could use the indication equation to find the exponents of the differential equation at x equals 0. And the indication equation is just this: r times r minus 1 plus p naught r plus q naught equals 0. So I plug in my p naught and my q naught into this equation, and then I just solve, and then I get a equation which I could factor, and I factor it, and I am left with r equals 1/2 or negative 3, and that's the answer for the exponents.